this fall it's 1,350, which, as you can tell, I'm really very fast to catch on to that. But anyway, this is section 5, so that's just to make sure everybody's in the right place. I'm teaching 2 Calc 1 sections this semester, so I gave everybody, or pretty much everybody, I think, a copy of the syllabus. They are also online, so I wrote it on the web, the syllabus that they're online. So since it's the same class, I figure I more or less kind of put it in the same website. So you're on this side, because this is section 5, section 4 would be that, and nothing would be really different, but I mean, I'm basically going to conduct more or less both classes the same way. Clearly, this class will have a different final than that class, so you gotta make sure you're on, aware of that. So let's see. I have one more syllabus if somebody else doesn't have it, and I don't know. Did I need more? Everybody has one. Everybody has one of these blue and one of these yellow. They didn't make it all the way there? Okay. One blue, one yellow. Okay, so I think I opened the wrong one, right? Since I said you're on that side and I opened the other side. Okay. There we go. All right. So first things first. We have 50 students, and I guess you can see how more filled we are. I guess there's 9 people on the wait list at this point, so that's basically why we're a little overcrowded. The 2 sheets that I gave you, one of them, the blue one, if I'm not mistaken, is a general sheet that basically tells you the resources. And this is kind of special if you're like a freshman that just started here. You might not necessarily know your way around the campus. The point is, on this floor, if you go towards the exit, underneath the staircase is where the Math Learning Center is, and they have the hours listed there, and they're very helpful, and you can basically go there and spend a lot of time doing your homework, or maybe form a study group and so forth. So the blue sheet is kind of more or less the math department's attempt to give out a little more information in the beginning of the semester to get people a little more ready for the class. If you are not aware of this, let me just say this, and I'm not trying to scare you, but the calculus sequence is actually, from students' view, one of the hardest sequences that you basically will find. And so, and we'll talk more about this as we go along, but the idea is you really have to start working first day of class. And besides the actual class time you put in, you should probably put in somewhere around 10 hours a week for the class, and if you don't, then you really, really will struggle mightily. There's a lot of concepts we're going to go through, and there's things, and I think one of the reasons why calculus is so hard is because it's a different class than what you're expected to seeing. It's concepts that are a little more, to some extent out there versus what you've, maybe have seen in college algebra or pre-calculus. Okay, so let's see. Textbook. This is your textbook. This is your Bible. There's 2 types of textbooks you can get. Let me borrow this for a second. If you're only planning on taking Calc 1 or 2, then you can take the thin one. If you're actually needing to take Calc 1, 2, and 3, then the thick one is actually the one you want. So this is basically single variable, and this is the multivariable. Multivariable is actually what you do in Calc 3. So to some extent it's kind of nice because I know they cost an arm and a leg, but technically, if you are actually taking all 3 calculus classes, then you only pay once for the textbook, and you're going to be using it throughout. What else should I say? My office is in the same building, so if you want to go towards the exit and you actually walk in the other side, if you go upstairs on the 2nd floor is where the math department is. My office is 277. It's written on the syllabus, and I put office hours basically right after this class. So I have them set up as Monday, Wednesday, Friday from 10:45 to 11:45. So I allowed for 5 minutes, I guess, to walk from here to upstairs. But anyway, the point is, I put them before, after the class. So I guess you're favored, because if you have questions, you can just walk with me upstairs. Assuming that you actually don't have another class coming afterwards. Email is a good way to get to me. I also put the website here. So so far on the website, what you can see is there's 2 things that I guess, even though there's 3 tabs, there's only 2 things in it. If you click on additional material, there's nothing going to show up there. That's going to be something that we're going to fill later on. So I put in the syllabus, and I put in a homework sheet, which is this particular homework sheet. Then I'll give to you at some point later on today. What else should I say? I'm guessing what you're really interested in is the grading. First of all, let me say this. Calc 1 deals with chapters 1 through 5. So that's basically what we're going to be focusing on. I put in some important dates to look at, like the last day to add or change sections or to drop. September 9th is called the census day, because from that point on you will be penalized for withdrawing. Actually, you can't drop from that point on. So the key idea is September 9th is the last day to drop. As soon as you want to drop from later on than September 9th, then you'll actually be penalized. September 17th and October 1st is if you actually drop out of all your classes, not just some of them. Let's see. So I'm going to say a quick few things about this, and then we'll come back to it. As far as the grading is concerned, you're going to have weekly homework that's going to be graded, and the way it's going to work, and you'll see this later on, I will usually assign probably a large number of problems, in the sense that from each section you're probably expecting to see pretty much every even problem in the section. And the reason why I'm choosing evens is because there's solution manuals out there, and I don't want to test you on your abilities to copy from the solution manual, rather than actually seeing how you can solve the problems. So usually the way it's going to work is you're going to be graded. The homework is going to be graded. There's going to be 2 components to the homework. Since it's going to be, let's say 20 problems, clearly nobody's going to grade 20 problems from every single person. And so the idea is that there's going to be maybe 3 or 4 problems randomly selected that are going to be graded. So the 2 components would be, number 1, the completion of the homework, and number 2, the accuracy of those particular homework problems. I don't know if I should say a bad habit or just a habit, but I have a very large tendency of putting problems from the homework in the quizzes and tests. So that's sometimes I'm trying to kind of reward people with that. The other 2 components, or the other 2 components of the grade will be tests and quizzes. Notice that I have written each test. There's going to be 3 tests, each worth 150 points. There's going to be a quiz and something called a pre-test, and I'm going to weight that, and I'll talk about that in a couple of minutes. And then the final exam, which if you haven't taken math courses at UCCS or any other university for that matter, and you have to take a bunch of math courses, just get used to that. It's going to be comprehensive. That's usually what the math department always does. So Okay, I usually prefer points. Maybe I should say a few words about this. I usually prefer points versus percentages because I find it's a lot easier for students to figure out what their grade is. And so let me just say a few words here now. You obviously can ask me if you want what your grade is at a certain time, but the reason why I write them as far as points is concerned because it's a lot easier. How is it easier? Well, all you have to do is take all your quizzes or tests or homework or whatever you were graded up until that point, add the total number of points that you scored up to that point, divide that by the total number of points you could be scoring, that's your grade. Okay, so it's a lot easier than trying to weigh. I have a 90% on the first exam. I have 50% on a quiz. Well, what's my grade? Well, what is the weight on each of every single one of them? So that's why I kind of choose them in this fashion. Let's see what else. Homework is going to be due at the beginning of the class. There will be no late homework accepted. We're going to drop the 2 lowest homework sets. And so basically that's one of the reasons why we don't take any late homework, because you can actually drop the 2 lowest homework sets. Another reason why we never really take late homework is because there's actually going to be a grader that's going to be grading the homework, and I'm not going to be the one grading the homework. There's actually going to be a grader, and I have to give it to him in a good amount of time so he can give it back to me. And if you get homework from different time zones, it's going to be hard. I think I changed it, but I forgot to change it in my syllabus. So let me see if I'm correct. Final exam, I'm sure everybody's going to be really excited about this. I'm really pumped about it. It's at 8 o'clock in the morning. Yeah, I'm joking. But anyway, it's December 15th at 8 o'clock in the morning. It's in the same classroom. Again, if you haven't been taking classes at UCCS, it's a 2.5 hour exam, so it's twice the length of the class. Okay, what else should I say? Oh, I was going to talk about the homework. Did I say that? Yeah, okay, so I actually have written in the syllabus that the homework is going to be due every Monday. That's actually what I did a year ago when I taught Calc 1 last time. As it turns out, I decided that I'm actually going to collect the homework every Wednesday. So that's actually something wrong in the syllabus. It's going to be collected every Wednesday, not every Monday. You can write it out on the syllabus, but in the end it doesn't really matter, because what I'm going to give you is this homework, and actually I guess I can probably do that right now. So here, if you can just pass them around. You'll notice that there's actually a due date written for each homework set. So the due dates are written on that piece of paper, so it shouldn't be that hard to keep track. You had a question, sorry.
No, I was just wondering, you say that the exam is on the 15th, but that's a Wednesday, not a Monday.
And I wrote Monday? I'm sorry about that then. If it's in fact a Wednesday, then
Just want to be sure if everything.
I will look at that again. I was making the syllabi for both sections, and I made one, and then I was using the one to make the other, and I think I changed the date, but I forgot to write the different actual day. So I will, I'll get back to you on that one. It's actually very easy to check out your final exams. Okay. The last page of your syllabus is, and I should have probably wrote it with bold capital letters and anything else on top of the table. It is a tentative schedule, and the key word is that it's tentative, in the sense that this is what I'm hoping is going to happen, and this is what I'm hoping that the flow of the course is going to be. But my main goal is to make sure that you understand the material. So if we have to go a little slower, then I can probably do that, just to make sure that we're covering something, or maybe I'll spend an extra day on a particular concept that the majority of you are struggling with, or so on and so forth. Okay, so today we're going to actually start talking about a little bit of a review, just to kind of refresh your mind. Oh, I forgot something. So since there's so many of us and we're trying to make sure we're all, I made a list. So there's a list which shows the 50 people that were actually listed in my class as far as the roster, which was last week. So it may or may not be actually of actual at this point. And then on the other side I have something I wrote as a wait list, and I put 12 numbers. I don't have any names there because I noticed that there's actually much fluctuations in the wait list, and I didn't get a chance to actually write them this morning. So what I would like you to do is two things. Notice that the first column, or you will notice that the first column says email address. I would like you to give me your email address that you're actually using on a daily basis. If I actually have to email you, I actually can get to you, because I know, and they probably tell you the orientation, and they probably tell you all throughout the time that, you know, you should check your UCCS email account at least twice a day, but I've learned to accept that that's not really what you do. So as a consequence, you know, I would like to actually get a current email. And then the other one is it's actually going to be the next three columns are actually today, Wednesday, and Friday. And I basically just, you know, I would like to write your email address and basically check the box for August 23rd if you're here. If not, I guess, you know, don't write anything. So, okay. Let's see. We're going to have a quiz in week 4, and then week 6 we're going to have the first test, and then so forth. Now, the thing that I want to talk about is something called the pretest. And this sheet that I gave away is called Calculus Pretest Instructions for Section 5. We are trying to make sure that everybody's actually in the right place. The key idea is that this semester is going to be the first time that we're actually going to do this particular pretest. Starting next semester, this is actually going to be transformed into a prerequisite test, which you actually have to take at home before you sign up for any courses. So you're going to have to take this prerequisite test to make sure they actually are well equipped to get into Calculus 1. So you have these instructions to use. You have to take this test by Wednesday. It is an online test. It is a pretty hard test, but the idea is it tests you on your pre-calculus knowledge. Okay? And we're going to accomplish a couple of things with this. First of all, what we're going to accomplish is the fact that I'm going to try and find out exactly more or less where you are in the class. Second of all, and even more important, is the fact that you can assess your own particular knowledge of the subject before getting into calculus. You will notice this, and you might think I'm just, lying right now, but for instance, trigonometry is one very huge part of calculus. And out of curiosity, how many of you have to take more than Calc 1? Okay. So the idea about the pretest is that there's 34 questions. You can take it online. Actually, you have to take it online, and the instructions are as follows. The one thing I should point out is the fact that the 16-digit code that you see written in bold, all the zeros are zeros and not O's. So when you type it in, there's no O's in any of the codes. The other thing to say is that when you actually register to take the quiz, when you select the university, you have to make sure you select the university as it is written here. So it has to be Univ of Colo SPR. There's a few other universities there that could be potentially interpreted as, University of Colorado at Colorado Springs. Okay? The people that set up these particular accounts set them up in that fashion. Let's see. When you log in, you will see that there's actually a few tests there. There's also something called a review for a test. I wouldn't bother to do that unless you really don't want to be sleeping for the next 2 days. The review for the test is basically like the entire pre-calculus book. So, if you really want to be spending, 24 hours trying to read it, be my guest. The point is, as I said, the test will actually be relatively hard, or not necessarily relatively hard. There will be some questions that are a little harder. There's going to be some questions that are a little easier. The whole point is to try and assess everything. This particular pre-test is worth 5% of your grade. So if you look at the points, it's actually worth 50 points, which might not necessarily say a lot, but if you think about 50 points out of 1,000, it's basically 5 out of 100, which means it's 5% of your grade, which is going to be the same equal weight for the quiz. Yes? Yes. You can only take it once. What I was going to do is actually, I actually took the test. I wanted to see, how well I'm how it's set up and everything else. So I actually took the test, and I'm going to try and actually pull it out to show you, or I'm going to try and actually, see what's going on. How exactly does the test look like? I wanted to show you basically how you write things in it more than anything else. The one thing I would suggest is you can either take this at home or you can take it on campus. The Math Learning Center has a lot of computers, and I personally would advise you actually taking it there. The reason why I'm saying that is because in case you have any problems trying to register, they're more or less trained into this, and so they can easily give you a hand if you didn't click the right button or anything like that. Versus if you go home, you take this, you go home, and then all of a sudden, you don't know what to do. Now, the reason why I want everybody to take this test before Wednesday before the beginning of class is because we can't be spending too much time on this, and then I actually need some time to figure out exactly where everybody's at. So it's not going to be that quick to go through 60 tests and kind of assess where you're at and everything else. So there's going to be a few things that you'll be tested on. There's going to be a lot of algebra that you're tested on. There's going to be some trigonometry that you're going to be tested on. Obviously, since you're taking it home, I should have mentioned something for the class. There will be no calculators allowed in any of the quizzes. Well, I guess in the only quiz and all the tests. Obviously, for the pre-test, nobody's going to be behind you to actually, watch you, so you obviously can use a calculator. And actually, moreover, the last two questions on the test, you do need a calculator to solve them. Between me and you, I don't necessarily care about the last two questions. So if you get them wrong, well, you get them wrong. Yes?
Is there time?
No. No, but I mean, one of the things you should do when you are attempting to take this test is actually have some paper and pen next to you. I actually started taking the test without actually having anything in front of me, and I was okay for the first few questions. And even though I can do a lot of things mentally, at some point you really can't do it without a paper. So, yes.
Is there a time limit on the quiz?
No, there is no time limit. But the whole point is, and again, this is a take-home test, okay? Even though it's worth 5% of your grade, be honest to yourselves and take it on your own without actually any help, okay? The whole point is, first of all, this is going to be in the end a prerequisite test that's going to be taken to see if you actually belong in Calc 1 or not. But this is a test so you can see actually where you're standing as well. So if you are using any other help besides yourself, then you're basically cheating yourself for the long run, because you might be lacking a particular skill at a particular point, and now would be a very good time to actually review it rather than going halfway through the semester and getting stuck at that point. If you notice the way I have it set up, and this is exactly why I have it set up in this way, and this is why I'm asking you to be honest with yourself, is notice that I set up a pre-calculus review for today, which obviously, considering I'm talking a lot, we're not going to have that much time for, which is fine because I don't necessarily want to spend a lot of time on it. On Wednesday, I basically have the entire day dedicated on, I just wrote pre-test because I figured it's easier to write pre-test than something longer, but the point is, that's going to be another review day in which you can actually come back and say, look, I really had this big issue with problem number 15 on my test that read like this. I have no idea what to do. Can you give me some light on that? Okay, and so that's more or less why I set up in this fashion. I figured it's a lot better to review on things that you're struggling with versus me actually just rambling through pre-calculus in an hour and you not remembering anything. Do you have questions? Yes.
How many questions are on there?
34. Yes. That's a very good question. I think it does. I'm pretty sure it does. I think I heard something about that. So, let's see. Anything else? And feel free to ask questions at any given point. I see some familiar faces of people that I actually taught in the past. So if you were my student in the past, then you probably are familiar with me. I have a tendency to talk a lot. So, I kind of go on a rampage once in a while. So, you can stop me at any point and actually ask me something about a particular thing. So let's see. Okay. First homework is due, I guess, in case you haven't seen, first homework is due the following Wednesday. So clearly we're starting a little slower with this particular week, but from that point on, starting Wednesday, we're going to have a quiz. Homework due every Wednesday. Today, apparently, I'm very, I don't know, loopy would be the right word. So if you go to mymathtest.com, it looks like this, okay? And so let's see. There's a couple of things you want to do. You can do. One of them, you can, if you already created a username and account, you can actually go and look at it. One of the things you can do, and I probably should have mentioned this, once you take the test and once you complete the test, you can actually go back, see how many questions you got wrong, see. You can relook at your answers. You can see exactly what, obviously the test is not going to tell you where you got wrong, but it'll tell you what the correct answer was, or you could see, actually it won't tell you the correct answer, but it'll actually tell you which problem you got wrong, and so you can basically rework it if you want and try and see if, if you get a better answer or different answer. Some of them are multiple choice. Some of them are not. There's a few problems that are actually involving graphing. So I'll come back to, I'll mention a couple of words about that if you don't remember much about graphing, either polynomial functions or I guess trigonometric functions. They're both going to show up on the test. Yes?
Do you need a graphing calculator?
No. As I said, you're not going to be allowed any calculators for any of the tests, and mainly the whole point of that is I've in the past allowed calculators for a variety of classes, and I've seen people focusing more on trying punching the numbers in and rather than actually trying to figure out the answer. And we're going to be looking at a much more about the concepts of calculus versus actually if you know how to divide 10 by 2. So the problems that you're going to see on the quizzes and the tests should be not requiring a lot of algebra. Okay, so let's see. So if you go to register, this, basically, these instructions are literally, page by page, click by click, as what you actually have to do. So, let's see. You can accept the privacy. It asks you for a login name, username, or account. It asks you if you have a person account. You can say no, and then the access code will be this lovely, very short code that you have here. And Sharon, actually, who's in charge of this particular project, typed all of these by hand, so she had a lot of fun with them. But anyway, this is basically the codes, and then you can proceed on. So let's see. You can create a login name and a password. It's a good question. What should I do? Problem is I already registered, so I can't register again. So let's see. I want to see if I can remember. So after you register, this is basically what you're going to be looking at. Okay, so I'm not going to basically go through all of these lists, but the point is, once you're actually registered and you're actually logged in, this is the page you're actually going to be looking at. Okay. This particular code is unique to your class, and so when you use this particular sheet, it'll tell you that you're in section 5. Okay. And notice that there's a pre-calculus placement, college algebra, and a calculus placement. And the one you want is actually a calculus placement. Okay? Is that making sense? Now, as it turns out, this is actually my account, in the sense that this is actually what I'm going to be using to look at all your test scores. And so this is why there's no results and anything else. But anyway, do you have any questions? Okay, so I'm going to close this because we've seen it. Okay, so let's see, what else do I need to say? Oh, yes, very important. The yellow sheet of paper that I gave you is a course that is called it's actually a sequence. It's a year-long sequence. It's called Math 131, Math 132. It is taught by Professor Gene Abrams. If you actually were at the commencement, then you actually heard him give the 5,000th lecture, I think he was called, his talk. Or you just skipped the commencement and went directly for the food. Anyway, the point is, if you find Calculus 1 to be very challenging, this class meets 3 times a week. It's a 4-credit class, which means the pace of the class is quite fast. The alternative is, if you take Math 131, Math 132, it's a year-long sequence for Calculus 1. There are 2 3-credit courses instead of 1 4-credit course. And so as a consequence, it goes at a much slower pace, and so there's still some seats available for that class. I believe he still had like 17 seats as of last week, as in the sense that there's actually still room to register. That might change in the near future. So especially for those of you who don't have to take more than Calc 1, this could be a very viable option, considering you basically can take it a little slower and make sure that you understand everything. The one thing I should caution you is the fact that, as I said, this is a 4-credit class. That's a 3-credit class. So if you wait too long to try to move into it, keep in mind the fact that you're going to be having one less credit, which may or may not have an effect on your student loans or eligibility or any thing like that. Okay. So do you have any questions about this? Yes.
Is this an online class too?
No. I believe this is the only math online class for Calc 1. From my personal experience, I actually had a few students last year that signed up for my 135 class and then later on decided that it's actually, or not decided, but they realized that the pace was actually too fast for them and they switched to 131 and they were actually very successful and very happy with it. So it is actually a great opportunity to do that. And you're in the position in which you can actually take advantage of this opportunity because it only starts in fall. So it's a year-long sequence that only starts in fall. So the point is, if you would have started in spring, you couldn't actually take this since 132 would be in spring, not 131. Okay. Questions, thoughts, ideas?
Will the test and quiz date and class dates ever change from what's on the syllabus?
They could be. They could. I don't intend to. But as I said, this is a tentative schedule. Nothing's really written in stone in the sense that I am your servant to some extent, in the sense that I want to make sure you're understanding things and you're actually following things. And so, for instance, the material covered on the tests might change in the sense that maybe we don't actually cover everything that I put there. Or we get to a point in which everybody says, we're really struggling with this concept, can we delay the exam by a day or something like that? And, the only thing I should say is that the exam dates or quiz will not change unless basically the entire class decides to do that. So the point is, if, unlike a democracy, the majority does not rule, considering that's actually what's written in the syllabus. And so the point is, every single person in the class has to be okay with that because, well, that's the schedule that I gave to begin with. So, okay. Anything else? Okay. So let's see. I have a feeling I forgot a bunch of things to say. Anyway, you'll find out later on, which may or may not be a good thing. But anyway, I'm joking. All right, so let's see. That looks incredibly ugly. I should have probably pointed out that, and you can probably see that in the syllabus. My full name is Dr. George Russ. I got my doctorate about a year ago. I don't necessarily care how you call me. I mean, you can basically, if you want to call me Dr. Russ, you can. If you want to call me George, you're more than welcome. I'm not really that strict on things, and as you'll probably see later on as well, I'm not really, if you have a question, fun. Well, I figured you were bored, so I should have entertained you. Okay, I haven't used this in about 4 months, so give me a little time to get used to it. So let's see. What don't you remember? Let's start off slowly. What is this? What is it? So it's the equation of a linear, or it's a linear equation, right? Yes?
Yes.
In which you all like to call this the slope-intercept form, right? So what is the slope? What is the intercept? Wonderful. Okay, so linear equations are what? Equations in which what has to happen? What is the difference between a linear and a quadratic?
Power function.
The power, right? The linear function is another way of saying that x is the first power, right? A quadratic equation will have the form in which x is actually at most second power, right? So a linear equation actually the general form of a linear equation is ax plus by is equal to capital C, but I know you don't like this because you really like the slope point form, the slope-intercept form, right? I know you really like it. As it turns out, I don't really care about it. Why? Well, we'll find out as the semester progresses. Calculus 1, there's 3 really big components of Calc 1, and they kind of stem one from the other. Well, I guess the last 2 are not really, well, you'll see. But the point is the following. The first part of the semester we're going to spend talking about limits. Second part of the semester we're going to talk about derivatives. And third part of the semester we're going to talk about integrals. And you'll see how one connects into the other and so forth. One of the things that we're actually going to be looking at is slopes of tangent lines and equations of tangent lines. And we'll come back to tangent lines, and we're actually going to talk more about tangent lines. But if you remember at all from pre-calculus or from college algebra, I guess, what is a tangent? Well, first of all, tangent line suggests that it's a line. And so the idea is there's a couple of ways in which you can actually describe a line. So one way of describing the line would be that y equals mx plus b, where m is the slope and b is the y-intercept, right? So far, so good? Okay. A form that we're actually going to be using a lot more in this course is y minus y1 is equal to m times x minus x1. Anybody remembers what this is called? The point slope form. The idea behind this is the fact that instead of having the y-intercept, we actually have a random point and just the slope. Now, as it turns out, I know you all really like this. This is just a generalization. If you actually think about this particular point as being 0 and wherever you cross the y-axis, so if you're thinking about the y-intercept, that would be 0 and b. Well, if you put in 0 and b here, this drops, this is b, so you just get y minus b is equal to mx, which means y equals mx plus b. Right? So it's again a generalization. Now the reason why we actually do this is because, again, the whole point is in Calc 1, when we actually come and start talking about derivatives a lot, we're going to talk about tangents at a particular point. So you're going to have this particular graph going around, and then you just pick some point on the graph and you want to find out the tangent line of that point. Well, because it's at some random point, the y-intercept is going to play absolutely no role. So we'll see more as this progresses. But anyway, so this is that. So now if I look at y equals ax squared plus bx plus c. What do we call this? A quadratic equation? right? Okay, so let's play, bless you, let's play a little game. What's the y-intercept? C? Right, so the way we usually write y-intercepts, we say y equals to C, right? Okay, continue on the game. What's the x-intercept? There is a reason why I'm coming to this particular junction of time. The quadratic formula, right? How do you determine y-intercepts? Do you remember that? Maybe I should come back to that and start off with that. How do you determine y-intercepts? Very good, but how do you determine y-intercepts? Plug 0 in for x. So you set x equal to 0, which will give you y is equal to c. How do you get x-intercepts? You set y is equal to 0. Is everybody remembering why this is the case? X-intercepts happen where? When your graph crosses the x-axis. What is the value of y when x crosses when the graph is on the x-axis? It's 0, right? Should I draw the x's, or is this pretty clear? Similarly, and obviously for quadratics or for linears, it's a lot easier to look at the y-intercepts. But what if I actually throw in some trigonometric function there? Then it might not necessarily be that clear where you're actually looking at, right? Does that make sense? That's why I said. So if I would say y equals sine of x, where is the y-intercept? Zero. Why is it at 0? Because sine of 0 is equal to 0. So the point is, you put in 0 for x, and you see what you come up with. Okay? That's why I was, yes, for a quadratic, it's quite obvious that it's the c is the y-intercept, but I just wanted to give you a little more in-depth ideas where you get that. Okay, so set y equal to 0. And now, what was that? X equals minus b plus or minus square root of b squared minus 4ac all divided by 2a. Wonderful. Do you remember this? If not, just nod. Then go home later and read it again. Obviously, this is something you need to know. Do you remember what this quantity is called? It's called the discriminant. There's 3 cases for the discriminant, right? If this is less than 0, then you're looking at complex numbers. Do you remember complex numbers? Which means if this is complex, then you have no x-intercept, right? Another solution is what happens if this is 0. Then you get 1 x-intercept. And if this is larger than 0, because of the plus and the minus, you get 2 x-intercepts. As a consequence, I kind of actually answered my next question. How many x-intercepts can you possibly get for a quadratic equation? 2. Everybody understands why 2? Yes? If not, just think about a graph. A quadratic equation has a graph of this nature if a is positive, or the other way if a is negative, right? Well, wherever I put my axes, so wherever I'm going to actually place this on my system of axes, my horizontal line, my x-axis, will either not cross the graph, cross it in precisely 1 point, or cross it in 2 points. There's nothing else to get, which means you either get 0, 1, or 2 x-intercepts, right? So a 5th order polynomial would have how many possible x-intercepts? 5. Does that make sense? Yeah? Okay. So now let's play another game. If I say x squared minus x minus 6 is equal to 0. Oh, sorry, not equal to 0. Is strictly bigger than 0. Can you tell me when is that happening? By the way, I'm kind of cheating. Your pretest is supposed to be testing you on your abilities at this particular moment. I'm basically helping you out here, because this is stuff you're actually getting tested on. Yes?
It can not happen when x is equal to 3 or negative 3.
You sure about negative 3? Put in negative 3, you end up with 9 plus 3 minus 6, which is 6, which is positive, right? Okay, the whole point is when you solve something like this, by the way, this is one of the things that you're actually going to be tested on is inequalities. One of these things that you have to keep track of is your answer cannot involve just a point or two. The answer is actually an interval, or maybe 2 intervals, or maybe 15 intervals. But the point is there is actually a wide range of values for which this actually happens. Do you remember intervals? Because, by the way, your answers for the test are actually going to have to be given in interval notation. So do you remember intervals? Yes?
No.
No. Okay. It is okay to say no, by the way. I'm not going to hold it against you. Okay, so the idea is the following. First of all, I guess before I actually start talking about intervals, how about I do this, and this is actually a review that I do before I actually teach college algebra or something like that. But nonetheless, let's just refresh ourselves a little bit with this. What are whole numbers? 1, 2, 3, 4, and so forth. Everybody remembers this? I guess it depends on which book you're opening. Some books actually have 0 as part of whole numbers, some people don't. I don't know if 0 would qualify. What are integers? Integers are all the whole numbers plus all the negatives of the whole numbers. The way we usually write that is minus 4, minus 3, minus 2, minus 1, 0, 1, 2. I shouldn't have started at 4, that's too much. Dot, dot, dot before, dot, dot, dot after. In notation form, and you're actually going to see me write this a lot, is capital Z with a double bar. That's actually how integers are defined, or that's the notation for them. Next, rationals. Anything that you can write as a fraction. So anything of the form m over n, where m and n are. Why not? Let's throw in another confusing thing. Do you know what that says? An element of the integer set, which means both m and n are integers. And obviously n can't be 0 since you can't divide by 0. Does that make sense? Yes? So anything that you can write as a fraction, and as it turns out, again, I don't know if you remember this, is 1.7 an integer? No? So is 1.7 an integer? How about if I write it as 17 over 10? Is that an integer? Why not? It's an integer. Oh, sorry, an integer. A rational. All right. So, this is the first class I'm teaching today, so it should be fun by the time I get to the third one. So, anything that you can actually write like in this form is going to be rational. Okay. As it turns out, any number that has a finite number of decimals can be written as a rational, right? Because all you have to do is just write all those numbers divided by whatever power of 10. Okay, irrationals. Oh, by the way, the rationals notation is a Q. That's the standard way of denoting rational numbers. Irrationals. Yes. The precise definition, which is not really precise, I guess, is irrationals are any numbers that aren't rational. So, we know, let's say, I guess, two very distinct irrationals. One of them is pi. Another one would be e. And then we have a bunch of them. Square root of 2, square root of 3, square root of everything else that's not a perfect square. Is that making sense? Okay. As it turns out, and this is beyond the scope of this course, but as it turns out, there's actually way more irrational numbers than rationals, which may seem very odd considering the only ones we're talking about is like square roots or, pi and e. But as it turns out, there's a lot more. Okay. Real numbers? Well, as it turns out, whole numbers are included in integers. Integers are included in rationals, right? And so basically the only thing we have to talk about is rationals and irrationals make up the reals, right? But yes, to some extent, every single number you can think of is actually a real number, right? So, all numbers, each. And the notation for that is capital R with a double bar. And of course, since we talked about the quadratic formula, how about complex numbers? Complex numbers are of the form a plus ib, where a and b are real numbers. Is that making sense? A is called the real part, B is called the imaginary part. Anybody remembers this? Yes.
What does I mean?
I is defined to be the square root of minus 1. The equality with 3 bars is another way of saying it's defined. It's by definition, basically. So it's not that it's equal, but it's actually, that's how we define it to be. Since they're complex and I is an imaginary number, which basically means that we don't actually have it, we just imagine we do, so, Okay, is this making sense? Alright, intervals. What does it say, what does it mean to look at the interval from 1 to 2? Yes?
And you look at all numbers, decimals, and otherwise between the number 1 and 2.
Basically what we're saying is I have to look at every single number that's strictly bigger than 1, but it's less than or equal to 2, and it can be any number that we discussed above, which means it can be any real number between 1 and 2. The one thing that we should stress about is the fact that a regular parenthesis means that the number 1 is not part of the interval. The bracket means that 2 is in fact part of the interval. If you're more familiar with a graphic notation, which I don't necessarily care for, but let's just actually draw it to have it. what it says is that I'm looking at this piece with a hollowed 1 and a full data 2. Yes?
Does that include the complex?
No. As it turns out, we don't really talk about complex numbers too much. In calculus, we don't really talk about them that much, especially in the beginning parts. They actually come up later on. But the point is, like for instance, when you are solving for the x-intercept, you should be at least familiar with what complex numbers are. And but no, we don't really talk about them too much. Is this making sense? Okay. If I say, so now if we come back to, what was it, x squared minus x minus 6 is bigger than 0. Right, because that was the original question we started with, and the question was, when is that happening? For what values of x is that actually happening? So, now keep in mind that your solution should actually be a whole interval. Well, as it turns out, it's actually going to be more than one interval, right? I guess I forgot to mention something, but I'll mention that as we solve this. So how do we solve this? Factor it. Okay, so we get x minus 3 times x plus 2 is bigger than 0. Right? Now what? Sorry? Okay, x is equal to 3, x is equal to negative 2. What next? Keep in mind what we're actually solving for. The whole idea behind this is we're actually solving a inequality in x, right?
So the answers are all numbers including 3 and greater than 3, and all numbers including negative 2 plus the negative.
Are you sure about that?
Don't just go plug it in the original equation. Oh, yes,
That
not
we tested.
including everything greater than.
Test it. Right? The way you were taught in pre-calculus was I have minus infinity to 3, then I have 3 to negative 2. Wow, I'm so glad this is recorded for posterity. Minus 2, minus 2 to 3, 3 to plus infinity. Right, so the idea is those are the 2 points in which my solution is 0. And so that basically forms 3 intervals. And the way we learned in pre-calculus to solve these is to test each of these intervals to see if you're actually if your inequality is in fact true or not, right? So for instance, you put in negative 3, plug it in. As it turns out, it ends up being 6, which is bigger than 0, so this works. Put in 0, you end up with negative 6. That's clearly not bigger than 0, so this doesn't work. Put in 4, and you end up with, what, 6 again? So you end up again with bigger than 0, so it works, right? And so as an answer, we're looking at minus infinity, negative 2, union 3 plus infinity. Does that make sense? Yes.
That we're expecting in the pretest.
That is what they would expect on the test. Now, on the pretest, by the way, I should point out one thing. One thing you might wonder yourself is infinity, union, and you'll have some problems involving pi and e. Well, you can look as much as you want on the keyboard. You're not going to find those. As it turns out, when you solve the pretest, or when you actually work with the pretest, on the left side of your screen, there's going to be a little box with infinity, pi, e, union, intersection, and whatever else you might need for that particular. For instance, there's going to be, I don't know, how many of you actually ever use like equation editor in Word? There's a, for instance, on the left side of your screen, there's going to be something that's going to look like this. would you know what that is? Fraction. So the point is, if your answer will involve a fraction, you click on this, it'll come up with a bar, you type in whatever's in the numerator, and then you go and type in whatever's in the denominator. Does that make sense? Similarly, there's going to be another one that's going to look like the square root with a little box here and a little box there, which will basically say, if I have like the cubed root of something, then you have to use this symbol. Is that making sense? Okay. Now, the last thing that I want to talk about, because I on purpose came up with that particular problem for a reason. So let's come back to the equation x squared minus x minus 6 bigger than 0. And for the sake of the argument, let's think about the function f of x is equal to x squared minus x minus 6. Can you sketch the graph? And there's two things you should think about. First of all, this is a quadratic, right? It'll either look like a U or it'll look like an N, right? Does that make sense? That's what you're used to seeing in quadratics. How do you know if it's a U or an N? If the leading term, which is the number in front of x squared, is positive, you're looking at a U. If the leading term is negative, you're looking at an N. Does that make sense? In our case, it looks like a U, right? What else do we know? We just solved the fact that x is equal to 3 and x is equal to negative 2, right? We just solved them right there. What are these called? The x-intercepts, right? So sketching my graph, and I don't necessarily know how accurate it is, but sketching my graph, if this is negative 2 and this is 3, then my graph is going to look like that. Right? Everybody understands this? I don't have to be very accurate about it. And the reason why I'm bringing this up is because you don't need to actually test the intervals if it's a quadratic. Why? Well, if I come back at this and I ask you, for what interval is this inequality bigger than 0? Well, look on the picture. Being bigger than 0 means f is bigger than 0, which means you have to be above the x-axis. Well, it is above the x-axis. Yes?
Okay, so the coordinates negative infinity, negative 2 represent the left side of the line.
This branch.
0. Okay.
I get a bunch of colors here, so I get to, play around and... So let's see, how about green? I know, sorry, you only have one color, which is probably pencil, so... Is this making sense? Alright, so, everybody has the, besides the actual papers, besides the actual syllabus and the homework, which you can actually find on the website, does everybody have a copy of this?
I'll be there.
And as I said, you have until Wednesday before class to actually take the test. Obviously, I can't actually block you out past that point, but whenever you take the test, it's actually dated so I know when you took it.